expand this is what's going to give you. Okay, somebody said I should expand it. Now let's expand. 2as equal to v plus u into v minus u. So that means it is equal to v times v minus u. So v into v minus u, then plus u again, plus u into v minus u. What have I done? I have used v to multiply the 2, which is here, this one. Then I have used u to multiply the 2 also, which is here. That is how to expand. Now, expanding each one, v times v is v squared. V times u is uv, is minus uv. Then u times v is also uv here, which is plus uv. And u times u here is u squared, but minus times minus is already plus. So you can see we have v squared. Here is minus uv plus uv, cancel out. Then you have plus u squared, plus u squared. Now you can get it. So we have 2as that we started with. 2as equals to v squared plus u squared. Then if you take this u squared to the other side, it's positive, so it's going to change to negative. So 2as minus u squared equals to v squared. And we have our third equation, which is what? V squared equals to u squared minus 2as. Yeah, notice there was something wrong at the middle here. So we have v into v minus u plus u into v minus u. From where? From our 2as equal to v plus u into v minus u. So I said this is what it's going to give us. But let us try and expand. So v times v is v squared, and v times u is uv, but minus is there. So here, positive times positive is still positive, so uv, uv. Then positive times negative is also negative. That is where it was wrong before. So we have u squared minus u squared. Then what do we have? We have v squared, this cancel out this, minus u squared. So equal to our 2as. So we have 2as equal to v squared minus u squared. So your u squared, negative u squared, comes to this side, become positive. So 2as plus u squared equals to v squared. And that's it. That's our equation. So we have v squared equals to u squared plus 2as. So that's it about the equations of motion. The next thing for us to do is to look at how to use them, when to use them. What kind of question do we have that will make us use this? Now we are on to examples on equations of motion. So example 1, an object was set in motion from rest till it attains a velocity of 18 meters per second in 3 minutes. Find its acceleration. Take note, whenever you see from rest, means it was not moving before. Therefore, its initial velocity is 0. Then it attains a final velocity of 18 meters per second, which is v equal to 18 meters per second. And the next thing we were given there is time. They said in 3 minutes. Time equal to 3 minutes. Now looking at this, we have v, we have u, we have t. Then the equation of motion that we are using is first equation, which is v equals to u plus at. We're looking for acceleration. So acceleration, as we've been asked to find acceleration. Put in your v is 18 equal to, the u is 0. Then plus acceleration times time, which is 3 minutes. So we have 0 is here. So 3 times a is 3a. So 3 acceleration equal to 18. Then you divide both sides by 3. Divide by 3. Then what do you have? You have 3 cancel out 3 here. Then 18 over 3 is 6. So that means acceleration equals to 6 meter per second squared. Take note, whenever you are asked to find anything in physics, you must put your unit. Unit of acceleration is this, while unit of velocity is meter per second. Unit of acceleration is meter per second squared. So we are going to look at another example. Now to the second example, a moving body accelerates from 5 meters per second to 9 meters per second in 15 seconds. Find that acceleration. So when we talk about accelerate from something to something, that means the acceleration is changing the velocity. So it has changed the velocity from 5 to 9. So we want to find acceleration. We can use our v equals to u plus at again. Then we're looking for acceleration, but here we can say acceleration is already v minus u over t. If you make that acceleration the subject of the formula, and that is the definition of acceleration initially. So what is our final velocity? That is 9. It reached 9 from where? From 5. 5 is the initial. So 5, 9 minus 5 all over t, which is the time is 15 seconds. So over 15. What is 9 minus 5? And that's 4. Then over 15. So that is 4 over 15. Then you're going to convert that to decimal to value the acceleration. So 4 over 15 is 0.267, and approximately you say that is 0.3 meters per second squared. So you're going to give me some questions at the end of this lesson, so just pay your attention. We're looking at another example now. Let's just digress from these equations of motion. We derived something the other time, which is F equals to ma. Let's say we have a question and say a force of 12 Newton acts upon an object. A force of 12 Newton acts upon an object of mass 30 kilogram. So now say what acceleration? Because you know, if a force is acting on something, it's changing the motion. That means that body is accelerating. So what acceleration is given to the object? So the moment you hear force, acceleration, mass, then you should know that the solution is F equal to ma. F equals to ma. Now we are looking for acceleration. So acceleration here will be force over mass. And what's the force? 12. What is the mass? 30 kilogram. 30 kilogram. So then you reduce it to lowest term and change it. So how many 6 is here? That is 2. Then how many 6 is here? That is 5. So 2 over 5 is 0.4 meters per second squared. So always remember your acceleration, the unit is meters per second squared. We look at another example. Now the next question goes, it says a vehicle starts from rest and travels. A vehicle starts from rest and travels for 30 minutes at 8 meters per second squared. How far has it traveled? Now, if you look at what we have been asked to find, we are looking for displacement. How far has it traveled? Then we've been given the time to be 30 minutes. Also, what were we given? We're given acceleration. Acceleration equals to 8 meters per second squared. And we're given velocity. Is there any velocity in this question? Let's see. What is velocity? It said it starts from rest. So that means we're given initial velocity to be 0. U equals to 0. So when you look at all these things, the displacement, time, acceleration, and that is the second equation of motion. So S equals to ut plus half at squared. Because our initial velocity is 0, this is cancelled out. 0 times anything is 0. So we are left with S equals to half times acceleration times time squared. So we're looking for S. So definitely half times, what's our acceleration? 8. What's our time? 30. 30 times 30. Here we have 2 here 1, 2 here 4. And we have 30 times 30 to be what? 900. So that's 900. And 900 times 4 will be what? That's 9 times 4, 36. So that's 3,600. So the total distance traveled will be 3,600 meters. And you can change that to kilometer and say your S equals to 3.6 kilometer. That's by dividing by 1,000. So that is when to use that kind of formula. We'll look at one more example before we round up. So here comes our last example for today. A vehicle travels from rest at 10 meters per second square to cover 30 meters. Find its final velocity. Which of the equations of motion talks about v as final velocity, and as we have v, we're looking for final velocity, u has been given to be 0 because it starts from rest. Then acceleration has been given to be 10 meters per second square, and also we've been given the distance, which is the displacement, and that's 30 meters. So which of the equations of motion? That is the last equation of motion, third equation of motion. So we have v squared equal to u squared plus 2as. V squared equals to u squared plus 2as. So what do we put in? We're looking for v. So v squared equal to, our u squared is 0 because u is 0. So that is 2as. So we have v squared equals to 2 times, what's the acceleration? That's 10. And the displacement is 30. So 2 times 10 times 30. 2 times 10 times 30. That is the 2as there. So v squared equals to, what's the 2 times 30 is 60. 60 times 10 is what? 600. Then we have v will be square root of 600. And the square root of 600, 24.49, approximately 24 meters per second. Don't forget the unit. And that's it. We have been able to use the equations of motion, which is v equals to u plus at, s equals to ut plus half at squared, and v squared equals to u squared plus 2as. Thank you very much. Expect your assignment soon.